Hi, hello, my name is Kiran Kumar. I am your physics lecturer. Today topic is velocity acceleration of a medium particle, and also we will discuss linear differentiation equation of the wave. Welcome to my channel Nature of Physics and Art. See, considering a displacement of a medium particle, that is y, which is equal to a sine omega t minus kx. See, sometimes we can write here y, which is equal to plus or minus a sine omega t minus kx. See here, why we are considering plus or minus? Here amplitude is positive and also negative. That's why we can consider positive amplitude and negative amplitude. What is amplitude? The maximum displacement of the particle from the mean position. See, and here differentiation with respect to time, then we will get the velocity of the wave, that is dou y by dou t, which is equal to a omega cos omega t minus kx. See, dou y by dou t, that represent, that is velocity of the particle, which is equal to a omega, and sine theta, which is equal to root over 1 minus sine square omega t minus kx. Try to understand. Then the value is replaced from the equation 1. So then we will get Vp, which is equal to a omega root over, that is a square minus y square whole divided by root over a square. Square root cancel, a get cancel. So we will get velocity of the particle, which is equal to omega root over a square minus y square. And also we can write this equation, velocity of the particle Vp, which is equal to plus or minus omega root over a square minus y square. Why we are considering here velocity is positive or negative? Along the positive y-axis is positive, along the negative y-axis is negative, we are considering. Okay, then continuation conditions we can take. The first condition is if y is equal 0 at the mean position. This is the mean position. Okay, this is the extreme position. At mean position y is 0, then velocity of the particle omega into a, that is a omega. Simply we can write as a omega. So here velocity is maximum at the mean position, and at extreme position, if y is equal to a at extreme position, okay, their velocity of the particle is 0. Because of y is equal to a here, a square minus a square get cancelled, that is 0 into anything 0. Okay, like this we will discuss the velocity is maximum and minimum. Please copy this. Now slope of the displacement curve. See, this is the velocity of the particle and this is the theta, that is positive slope of the velocity of the particle. For this, here tan theta, which is equal to dou y by dou x, which is slope of the displacement curve. For this, here dou y by dou x, which is from the equation 1, a minus k cos omega t minus kx. See, we can write this equation dou y by dou x, which is equal to minus a k cos omega t minus kx. This is taken as equation 2. Okay, sorry, this is equation number 3 and equation 1 in equation 3. So then the resultant equation dou y by dou x, which is equal to minus k divided by omega, that is dou y by dou t. Try to understand. From this, here we can write here dou y by dou t, which is equal to a omega, that is here already a cos omega t minus kx is there, that's why 1 by omega, that is a cos omega t minus kx we can write. Okay, so from this equation here k by omega is 1 by v, that is dou y by dou x, which is equal to minus 1 by v dou y by dou t. Okay, so please copy this, then I can continue. Now from this equation dou y by dou t, which is equal to minus v into dou y by dou x. See, this is the velocity of the particle, which is equal to minus velocity of the wave into slope of the displacement curve. See, we got a relation, that is velocity of the particle is equal to negative velocity of wave into slope of the wave. From this relation we can find velocity is positive or negative. See, try to understand. In the first condition here theta is less than to 90 degrees. See, theta is less than to 90 degrees, and that is slope is positive. Here slope is positive. Then velocity of the particle is here negative. Reason is slope is positive slope, we can observe in the diagram. Then here velocity of the particle is equal to negative velocity of wave into slope. Slope is here positive, that's why here velocity of the particle must be negative. Next, see, in this situation theta is greater than to the 90 degrees. That's why here the slope is negative. We can observe here slope is negative. So here slope is negative. Then slope is negative, the velocity of the particle is positive. So Vp is positive. Reason is negative into negative is positive, that's why the velocity of the particle is positive. That's why here velocity of the particle in this situation taken positive y-axis direction. Here the velocity of the particle is negative, that's why taken along the negative y-axis. Please copy this relation. Now acceleration of the velocity particle we will discuss. See, here acceleration definition, the rate of change of velocity is called acceleration. Then here dou y by dou t, which is equal to Vp we got, and dou Vp divided by dou t, which is equal to Ap. Okay, see here AP, which is equal to, we can write dou Vp by dou t, which is equal to dou square y by dou t square. Try to understand. And which is equal to, here from this equation, minus a omega square sine omega t minus kx. So we can write finally AP, which is equal to minus a omega square sine omega t minus kx. Okay, so AP, which is equal to minus omega square a sine omega t minus kx is y. So this is considering as equation number 4. See, we can take two conditions here. First condition, if y is equal 0 at mean position, okay, at mean position, that is the value is a, which is equal to minus omega square into 0. So acceleration is minimum at the mean position. And one more condition we can take, that is if y is equal to a at extreme position, then a, which is equal to minus omega square into a, here y is equal to, I am writing as a, that is maximum displacement of the particle from the mean position. Here acceleration is maximum. From these equation we can consider at mean position the particle have the maximum velocity, that's why maximum kinetic energy, and at extreme position that have the potential energy only. Please try to understand and copy this. Now continuation relation, considering equation number 3, that is from equation number 3, partial differentiation with respect to x, that is dou square y divided by dou x square, which is equal to the minus of minus plus, k is common here, minus k, okay, that is minus is there, that is get cancelled, then a into k square, okay, and different partial differentiation of cos is minus sine omega t minus kx. Okay, see this equation is replacing in this equation, this is replacing here, then dou square y divided by dou x square, which is equal to minus k square divided by minus omega square. This, okay, value is writing as dou square y by dou t square. Please try to understand the steps. Okay, minus minus get cancelled. Here dou square y divided by dou x square, which is equal to 1 by v square, 1 by v square dou square y by dou t square. Okay, so then continuation relation here, dou square y by dou t square, which is equal to v square into dou square y by dou x square. So this equation is, we can write here, that is velocity of the acceleration of the particle, which is equal to the square of the wave velocity into slope of the wave, Okay, so this is the relation for the acceleration. Already we got one relation, that acceleration is a, which is equal to minus omega square into y, that is dou square y by dou t square, which is equal to minus omega square into y. Rearranging this equation, we can write dou square y by dou t square plus omega square into y, which is equal to 0. This is simple harmonic wave equation. Please copy this. Here one example problem. This is IIT JEE 2008 question. See, a transverse sinusoidal wave move along a straight in the positive x direction at a speed 10 centimeters per second. The wavelength of the wave is 0.5 meter and its amplitude is 10 centimeter at a particular time t. The snapshot of the wave, the velocity of a point P is given in the diagram when its displacement is 5 centimeter is. What is asking in the question? Velocity of the particle is asking. See the given values here, the velocity is given, the velocity of the wave, that is 10 centimeter per second, and here wavelength is given and amplitude is given and y value given, vertical displacement. Here velocity of particle we have to find. See, velocity of the particle, which is equal to omega root over a square minus y square. So Vp, which is equal to 2 pi mu, okay, into root over a square minus y square. Vp, which is equal to 2 pi, v is equal to, mu is the frequency, mu is equal to v by lambda, that is root over a square minus y square. Then velocity of the particle 2 pi into velocity of the wave is 0.1 given, and wavelength is 0.5 into a square value, amplitude is 0.1 whole square minus y value is 0.05 whole square. See, this is the given values are replaced in the above formula. Then velocity of the particle, which is equal to, that is 2 pi into 1 by 5, that is, okay, root over 0.01 minus 0.0025. See, try to understand. Okay, so then velocity of the particle, which is 2 pi divided by 5, root over the value is 0.0075, multiplying and dividing with 10,000. So divided by 10,000, the value is velocity of the particle, which is equal to 2 pi by 5, that is numerator value we can write as 75 is root 3 into 5 divided by 100. See, this 5 get cancelled and this is 50. So the answer is velocity of the particle is root 3 into pi divided by 50, that is meter per second along the positive x axis. Here direction just now completed in the derivation. Thank you very much.